Oh, I don't have that displaying yet.
Is the class actually down to this few people?
I hope not. I hope people are just running late. You don't want to miss the night before the test. I mean, when you miss this class, it's like missing a week.
Yeah.
Okay, let's see if that's coming up. All right, I'm going to give this out. I'm going to pause the recording right now. Got the recording going. Okay, so there's D2L for this class, and I added, if you go under content, a lot of people that take this class just forget their prerequisite materials. So here's what I added. If you click on prerequisite materials, if you've forgotten how to add and subtract polynomials, these are review videos, just short 5-minute videos maybe, on how to do all this stuff. This is the stuff you're supposed to know how to do already, but that you forget, and then we're trying to use it at a higher level, and you're lost. Okay, so I called it under content. Hello, under content. I called it prerequisite materials, and I have links to a bunch of short education videos by David Haga. I had to create all these links, but I didn't have to create the videos, so that's nice. So if you don't remember how to add and subtract polynomials, multiply polynomials, special products, how to multiply them, if you don't remember, this is that. These are, I've got all this information. This is like Math 1100, which you may have had, or maybe you tested out of, but you don't remember it. So you had it, but you know, after 6 months you forget it. So anyway, and then there's also review notes. These were the old Haga notes on exponents and factoring and stuff. So if we get into something and there's some graphing things, so there's short videos. If you have time to look at those might be helpful to you. Let me mark, let's see, I'm going to mark, are you Daniel Noonan? Are you Daniel? No, I guessed wrong. Let's see, are you Daniel? What's your name? Quentin? Oh, sorry. Okay. It's horrible. I am horrible with names, and then I haven't seen you guys in 2 weeks, so I don't remember your names. Okay, on this first thing I had you to turn in, I went ahead and gave you 100, even if it was wrong, which if you got a lot of green on your paper, it was wrong. So I don't want to really show anybody else's paper. If you have questions on it, we can go over it. But I don't see, people came in and got all my copies. I'd have to print it out. So somebody would have to print one out if you want me to go over it. We actually have 3 hours today to go through one section and the review for the tests, and that doesn't take 3 hours. So we're going to have a lot of time to do. I was going to work 1 and 2 together on this worksheet. Pass this out. And then the homework, which I was supposed to give you last time. We can work on. You guys can work in groups on that and do this homework. But right now I'm showing you on D2L. I added a whole bunch of links of preliminary material. So if you don't remember things, what did you?
Is it this?
Yep. Did you already work it?
Yep, I did. I'm good.
All right. Well, it may not be right though. So I'm going to work the first 2 problems, and then give you some time to work the 3 and 4 on the back. See if everybody understands it. make sure everybody understands that this is a pretty big part of the test, is understanding range and domain, increasing constant, all that. But so this is the prerequisite materials, and then under course home, if you click down here on integrity, you have to click there, and it takes me in here, and this is, I've got all the sections already recorded, you know, so this is the notes, and we go through so this is all the stuff for test 1. So that's integrity, and they're long recordings though. Like this one's 48 minutes long, this is 39, 38. But those little ones by Mr. Haga are shorter. They're not always to the depth we do in this class though. They're maybe more like prerequisite material. But so, did you want me to do, get back to here. I can bring this up. Did you have questions on under course materials, test 1? I don't know if it's going to let me print this out. The 1.2 on your own. I have the answers posted. Let's see if it lets me print. Okay, file, print. Okay, and it says I have $0 and it's not going to print. Oh wait a minute. Is it? Oh no, it charges to the math department. Okay. They're supposed to, you know, we're supposed to be able to print. So, somebody else. Print something. So do we need to go over, I want to make sure you understand this. Now, do we need to go over this? Because a lot of you didn't get it. We need to go over this?
Please.
Okay. So, whenever a graph stops at the edge, it means it keeps going. If it doesn't stop with the dot, either an open circle or a closed circle, it keeps going. So there's arrows there and there. And then this one has an open circle here, so it stops there, but it doesn't include the 4 on the x-axis, and it doesn't include the 2 on the y-axis. And this is a closed circle, and it stops there because it's a circle. And it does include the -2 on the y-axis, and it does include the -3 on the x. Okay, so that's how you read these things. Do we need to shut some lights off? Or can you see that?
Where did you find that to print that?
Oh, that is under content, on your own material, test 1 material, on your own material and extra handouts. And it's section 1.2 on your own. And I just click down here and it shows download, and then shows print when it opened in Word. Okay?
Section 1, 2 on your own.
Oh yeah, I gave yours back to you, but you want a clean one to start with. Is that right?
Yeah.
Yeah. All right. So back to this. And by the way, the stuff that is here with answers, you should work all that stuff. You should work that stuff. Like, and if we have time today, I'll work this one too with you. Yeah. Now I don't collect stuff that has answers, but this is similar to what's on the test. So I'm just printing out. I'm printing the 1.4 on your own out for later.
So all these on your own are basically what you're going to put on the test, that format, that kind of.
Right, and so it really helps you to go ahead and work them and check and make sure you understand it and compare it to the answer. Even though, so I don't collect it, but you know, it's there for a reason. Hi. Well, let's see.
And this extra practice, you were saying that it says something like it was supposed to be submitted on Dropbox.
Oh, okay. Well, I forgot to tell you guys about it, so.
But next time you'll probably want something that's like this submitted on Dropbox instead of
Yeah.
just handed to you.
Yeah. But I was gonna take it at the end of class today
Okay.
instead of having to do it. Just hold on to it, and we're gonna work we're gonna work one through together. This is yours, and I'm about to go over this. I gave everybody 100 for doing it, but it got green mark on it. Wasn't right. Okay. So.
Okay, it hates me.
It hates you.
That's 3 tries and just gave me a blank page.
Oh, what are you hitting?
I don't know.
You must be
Apparently
doing
it's
it
wrong.
wrong. You're doing it wrong. Okay, let's see. What are you telling it? What you got to do? No, it's better to hit that down arrow. No. Hit the down arrow, hit download, have it open in Word. You would have to actually or open it. Yeah, just tell it to open. Oh, it's in Adobe. Say accept. Okay. Now, okay. Okay. Print. I hope. Oh my. I think I probably had it posted as an Adobe file and a Word file. Okay, so the domain is all the values that X can be. This is, and we're writing it in interval notation. It's all the values, all possible X values, all the values that X can take on. So to find the domain, you can project to the X-axis, project the function to the X-axis. And this is Y and this is X. Okay? So if you project, this function keeps going up there. So you project to the X-axis. I'm just projecting. It keeps going at an angle, so it goes to positive infinity this direction and negative infinity this direction. So the domain, so what values can X be? It keeps going at an angle this way, so it goes from minus infinity to infinity. Do you see that? The domain. So interval notation means we either put a square bracket or parenthesis. So let me write the domain this way. X less than infinity, less than negative infinity. That's how you'd write it with less than signs. X between, that's how you'd write it. Interval notation, we write that as minus infinity to infinity. And that's how I want it. I don't want it this way, I want it this way. The domain is minus infinity to infinity, and that means X is between minus infinity and infinity. And when you're writing domain and range, you either use a regular parenthesis or a square bracket. You use a parenthesis when it's a concept like the infinities, because it really can't take on that value. You use the square bracket when it can take on that value. Okay? The range on this problem, so you project this to the y-axis to find the range. Projecting to the y-axis, pretty soon my function is going to be unreadable, but if you project to the y-axis, it keeps going up to positive infinity for y, and it stops, though, right here. This is a vertex, and it can take on the value of its vertex. So it stops at -2. It can be a -2. So you always start with the smallest number, so it's -2 to infinity. And that means that's interval notation. Range, of course, is all the possible y values. These are the y values. This is interval notation. That's the answer I want. It includes the -2. It can take on the value of its vertex. And this point is -3, -2 vertex. It can take on the -3 and the -2 here, but it didn't matter about the -3 because it didn't stop there on the x. But it started at -2, went to infinity. We include the -2 because if you plug in -2, you get -3. Are you Daniel?
Yeah.
Here's your worksheet. Oh, yeah, you can come up and get your worksheet. I gave everybody 100 even if it wasn't right. So we're going over it because they didn't understand. All right. So if you got a lot of green on it, it means it's not right. It would have been a lot lower grade, but your first worksheet, I just gave you guys 100 for trying it. Okay, so the y value, so this is interval notation. What this means, if I wrote it with inequality signs, it would mean -2 is less than or equal to y, which is less than infinity. Or we wouldn't even say anything about infinity. We would actually just say y is greater than or equal to -2. This is how we would write it with less than, equal, less than signs and stuff like that. We would write it like that. Yes?
So the brackets indicate a point, the parentheses is an infinity?
The bracket indicates it takes on that value.
Okay.
The parentheses, since it can't take on the infinity, is a concept.
Mm-hmm.
And it means it can't take on that value, actually. You can't say that it takes on. You can't say infinity is 10,000 and say it takes on that value. Every time you say infinity is 10,000, I can say it's 10,001, 100,000, a billion, you know. So we use parentheses to say that it can't take on that value. And this is interval notation. This is what I wanted for these first two answers. This is and then we wanted an interval notation. And this is what it means, that x is between minus infinity and plus infinity. And I projected to the x-axis to figure it out, and I projected to the y-axis. But this is its vertex. It can take on the value of its vertex. And you always do the smaller number on the left, the larger number on the right. Left to right. You always read graphs left to right, and in interval notation, you put the smaller number on the left, the bigger number on the right. Any other questions about domain and range in this one? Now that you can't read my graph anymore. Okay, the x-intercept or intercepts, well, it actually crosses the x-axis here and here. And I want ordered pairs. Don't just tell me -5 and -2. Well, -1, I mean. Okay. I want ordered pairs. When you're on the x-axis, what is y? So for x-intercepts, I want -5, 0, and I want -1, 0. If you were to graph this point, you would start at the origin and you go left 5 and up 0. Those are the ordered pairs. Like this ordered pair is -4, 4, because that's x, y. And I think I posted some videos about graphing coordinates. I'm not sure. There's all kinds of things in that preliminary. You guys that came in late in D2L, because a lot of people are struggling, and under content in our D2L, I put in prerequisite materials. And I put a bunch of links to very short 5-minute videos on how to do this stuff that you're supposed to know how to do. So if you don't know how to do this stuff, this is all about graphing linear equations using tables. If you struggle with graphing, for instance, you might want to watch these first 3. If you struggle with translating written phrases into algebraic expressions, you can watch that. This is systems of linear equations. We're not doing any of that. Let's see. Really, factoring review videos, quadratic equations review, and there's notes, radicals. So this was all from, if you struggle with this stuff, these are short videos. Like if I go to multiplication, it's in educrations, and so if you have a iPad, you can download the free educrations video. And this is David Haga telling you how to multiply polynomials. If you don't remember how to multiply polynomials,
anytime we are multiplying polynomials, we can use the distributive property.
Okay,
However,
we're going to stop.
when you are multiplying a line number,
But anyway, those are short videos. So I posted them. I didn't make them, but I linked them to my D2L, which took a while. But they're in there under D2L. And if you struggle with factoring, it may be because you don't know how to multiply the polynomials. So he goes through very slowly and goes through all that. We don't do a lot of factoring in this part. But all right, so we got the intercepts, x, y coordinates. Y-intercept. What's the y-intercept? It's 1, but I don't want you to just put 1. I want you to put the ordered pair. For this point right here, the ordered pair is the x coordinate is 0, because you go left or right 0, and then you go up 1, and the y coordinate is 1. So the y-intercept is 0, 1. You will not get all your points if you just tell me 1. And how do I know you know that it's 0, 1 and don't think it's 1, 0? So, and the next worksheet that I have you do, which those of you that came in late will have to get one of these. It actually has those explicit directions. I want x-intercepts and y-intercepts as ordered pairs. I want domains and ranges in interval notation. Okay, next thing. This is function notation, f of 2. Here's our function f, right here. What is f of 2? What's in the parentheses, that's your x value. So don't go to y, go to your x-axis. You need to know that's the horizontal axis. Go to 2. Go up to hit the function and see. Go over and see where it lands on y. That's 3. F of 2, when x is 2, y is 3. When you go up to the function and straight across and read y. F of 0, that's the x value. So On the x-axis, go to 0, which happens to be 0 for the y. Then go, but we're doing x, so you don't go left. You want x is 0. Okay? So x is 0 when you're on the y-axis. So go up to hit the function. It hits it at y equals 1. So that's 1. Okay, so that's why we didn't go this way, because that would be x is -1. Y is 0. Okay, the next one says, what values of x does f of x equal -1? So this is function notation for y. What we're saying is when y is -1, so go to the y-axis. So you go to the y-axis and look at -1. It's right here. Go across and hit the function. What is x? -2, and keep going. If it hits it more than once, -4. So this one, this is function notation. When you're f of something, that's your x value. You have to go on the x-axis, go up to the function, read off what y is when you hit it. You may have to go across. When it says f, for what values of x does f of x equal -1? F of x is function notation for y. Go to the y-axis, go to -1, go across and up to the x values as many times as you need to. The function hit it more than once, so we had 2 answers. All right, the next one, number 2. So the domain is the values that x can take on. So project this to the x-axis. So x goes from -3 to 4. But because of this closed circle here, it includes the -3. So we have a square bracket -3, comma. And then we have because it doesn't include the 4, that's an open circle, it's a parenthesis. And what that means is that x is less than 4 and greater than or equal to -3. Okay, that's with inequality signs, but this is what you need to know, interval notation. This is interval notation. This is the answer I want. If you put this answer, you might get part of the credit, but you've got to be able to write it this way too. Range, that's the values that y can take on. Project it to the y-axis. Just project the endpoints to the y-axis. And remember, you got to start from the lowest number and go up. So it's -2, and does it include the -2? It does, because it's a closed circle. Includes the -2, so it's a square bracket -2, and then it goes up to +2. Because of the open circle, it doesn't include. What does it mean? It means -2 less than or equal to y less than 2. The range is the values that y can take on. The domain is the values that x can take on. Okay, the x-intercept, just guess that it hits at about 0.5. When x is 0.5, when you cross the axis right here, the x-axis, what's y? 0. So I want that ordered pair. What about here? Don't forget the negative sign. I'm going to say about, it's 0 when you're on the y-axis. -0.3 or so. That's the y-intercept. Don't forget the negative sign. Okay, now you're going to do f of 1.5. So remember, inside the parentheses, that's your x value. Go to your x-axis, go to 1.5, go up to the graph, and then go left to read what y is. It's about 0.5 positive. F of minus 3, so that's the x value. You go down and right to see what y is, that's a -2. And then for what values of x is f of x equal -2, that's y. So we're talking about y being -2, so go to the y-axis to -2, go across and up, and it's -3. X equals -3 or just -3. Okay, does that help? All right, now we're going to do this first page together. So hopefully you're getting a little bit better at interval notation. We're going to do 1 and 2 together, and then I'm going to have you work on 3 and 4 on the back. Okay. So this specifically says state the domain range, increasing, decreasing, constant answers in interval notation. State all intercepts as ordered pairs, that's x comma y, and use decimal approximations as needed. So when this crosses here, we're going to just approximate it. It's hard to read. It looks like 2.5 maybe. It doesn't look like it's 2, and it doesn't look like it's 3, so. Okay, so the domain. So if you need to, you can project it to the to the x-axis. If you need to project it to the x-axis, I mean, this is going down at an angle. You have to assume it keeps going same direction. It's going down at an angle, so this keeps going to minus infinity in terms of x. This stops right here at 9. Stops at 9. Does it include the 9? No. So it'll be a parenthesis. We can't write 9 comma negative infinity because we got to go smaller number, larger number. So we got to write, and we never include the infinity, so it's negative infinity comma 9. And that's the answer to the domain. Yes?
Is it right if I print off the worksheet?
Sure. Sure. Oh, wait a minute. Here, I have a copy for you. I'm sorry. You guys that came in late, well, here, anybody else need it? I made copies. I gave Megan one. Did you get one of these? Okay. Do you want a fresh one?
No.
Okay. You got it. All right. Okay, so then the range is all the values that y can be. So if you need to, you can just project the endpoints. This is higher than this, so we're going to use this one. Because this spot would be taken up by this line. So we project to the y-axis, all this stuff. You know, this is projection to the y-axis. So this keeps going to minus infinity. This stops at 9, but it doesn't include the 9 because of the open circle. The open circle was down here. It'd stop at 7 and would include the 7 because that's a vertex. So it includes its values of the vertex. But here it's an open circle, so we don't include the 9. So the range goes from minus infinity comma 9, and we don't include those. So it just happens to have the same domain and range, okay? This example does. Okay, now here's increasing, decreasing, and constant. When we're talking about those, we want the x values where y is increasing, decreasing, or constant. Okay? And again, it's interval notation. Now, on the endpoints for these things, what can we say it's doing at x equals -6? It's changing, so we can't say. So on these, we always use, for increasing, decreasing constants, always use regular parentheses. This or this. Okay, just no square brackets. Okay, so we look at where's y increasing? We look at the graph left to right. Where it's rising left to right, it's increasing. Where it's falling, it's decreasing. And where it's level, it's constant. Well, this graph isn't level anywhere, so we'd say none on that. Okay? So this area is where it's increasing. And then again at this area. We look at where y is increasing here, but we want the x values. So projecting back to the x-axis, this is going down at an angle. We're going to be increasing from -infinity to wherever this stops. That looks like it stops at -6. And we never include the endpoints. So we want -infinity to -6. Does that make sense? Okay. And then here, where y is increasing, we look at the x values. We start at 5 and we stop at 9. We don't include the endpoints. And that's where it's increasing. That's interval notation. These things mean, what do they mean? And we don't want to, this isn't part of our answer, but this means it's increasing when x is less than -6, or between -6 and -infinity. And when x is between 9 and 5. That's what this interval notation means. That's what this means. So when you're talking about increasing, decreasing constant, it's always the x values. Okay? Falling, where's the graph falling? From left to right, it's falling here. It's
The presentation's not showing.
oh, it timed out. So it's falling between -6 and 5. And that's the x values. We look at where it's y is falling, and then we project back to the x-axis and see -6 to +5. So what does that mean with the less than sign? This is not part of your answer, and I have the answers posted. But -6 less than x less than 5. So we want to know where the x values, where y is increasing. So all this extra stuff I'm writing is not part of the answer, but I want to make sure you know what interval notation means. Okay. X-intercepts, and we want ordered pairs. So here's an x-intercept here at, and we want -7, 0. Because when you're at this dot, you're at -7 for x, 0 for y. That's x comma y. Here, we're at about 2.5, 0. And the next one at about 6, 0. Okay, so those are the x-intercepts. The y-intercept, there's only one, is at 0, 2. don't just tell me 2. The relative maximum, we don't count when we can't make, the definition of maximum, you had to make an interval around it, so when it's an open circle, you can't say that 9's the relative maximum, because it can never take on that value. See, the definition of relative maximum is you had to have it had to go like this or something, and you had to be able to come up with an interval of values where everything was less than that. So, at this y value, that would be a relative maximum. But you can't make an interval of values around this open circle because you can't, there's not this side. Now if this was, so we have a relative maximum here. This is a relative maximum. For relative maximum, we want the y value. And it actually says on the test, give me the y value. Okay? In the little writing up here, the reading, what it tells me I want, it says give y values. So look across at the y value, that's 7. Relative minimum is a y value, and it's at -2. Okay, is this a function? You can try the vertical line test. Can you draw a vertical line and go through more than one point? Anywhere here, can you draw a vertical line and go through more than one point? If not, then it's a function. Like a circle's not a function because you can go through 2 points with a vertical line. It is a function because you can only go through 1 point. No matter where you drew your vertical line, you'd only go through 1 point. You can go through 0 points out here, but it doesn't matter. It's still a function. If you go through 2 points, it's not a function. Okay? And then find f of 7. So which axis do I need to be on to find f of 7?
X.
X, right. So you go to 7 on X, go down or up to your function. Well, we go up and over and read off Y. That's 3. So it equals 3. Okay, for what values of X does f of X equals 2? So which axis do I need to go to for the 2? This is another way to write Y. So I need to go to the Y axis and find the 2. And then I'm on the function, go down to X, but go across at 2 and also go down at these other places. And go over here to the function. There's 3 places. So there's 3 answers here. So we've got it at about X is -7, X is 0, and X is 6.5. So there's 3 answers here. So you go to 2, you go on the y-axis, go to 2, and then go across to hit the function. Well, you're already at the function, so you go down and read the x value. Stay at 2, hit the function, go down and read the x value. Stay at 2, go across, hit the function, read the x value. That's how you do these things, reading graphs like this. Okay, and the next one is a piecewise function. Okay? Now, even though it asks for these values at different points right here, what I want you to do is make 2 sets. You're going to find it easier to make tables. Make 2 sets of tables. So look at x equals -2, this is where the function is changing. It doesn't have to change at the same place, but all these that I give you are. Okay. It could change at one place and have a gap, and then change it, have another number. It could have -4 here, or it could overlap, but. So notice that g of x is -2x plus 1 when x is less than -2. So let's make a table for -2x plus 1 when x is less than -2. X, y. But our open circle for this part of the graph is going to be when x equals -2 and you plug it in here. So I do have to plug in the -2 here, even though it's not valid here. It's an open circle. But that's where the graph starts, the left half of the graph starts. So I plug in -2 here, and I get -2 times -2 plus 1 is 4 plus 1 is 5. So that's my open circle for the left half of the graph. And now I have to go down, x has to be less than, so I can do -3, -4. Just plug in -3 here. -2 times -3 is +6 plus 1 is 7. -4 times -2 is 8 plus 1 is 9. And that's all I need. So this is the left half. So you go to the origin. I'm going to graph the point -2, 5. Go to -2 on x, up 5. That's our open circle. Then I'm going to go to -3 and go up to 7. I'm going to make a little dot, and -4 and go up to 9. And so this is the left half. It's a line, that's the left half.
Now again, did you know that that was going to be an open circle?
Okay, because x can't actually be -2 here,
Oh, I see, yeah, less than, not less than.
because it doesn't have an equal sign?
Yes, I see now.
Okay, okay. But that's where it's changing, so that's where the open circle has to go. But even though, so it's actually not defined at -2, 5. It's actually, the function doesn't take on that value. That's why we put an open circle. So when I say g of -2, I can't put 5 down. Okay. Now I'm going to make a table of values for x minus 3. When x is greater than or equal to -2, x minus 3. I have x, y. Okay. So I want to put in -2. This is where the right half starts, -2. And I put in that here, and that equals -2 minus 3 is -5. So this is the closed circle. And so over here, this actually equals -2 minus 3, which equals -5. So when g of -2, you have to go to this function because it equals -2 and put it in here. G of -2 is not equal to 5. It equals to -5. Okay, and then we can do 0. 0 is easy. Put in 0, you get -3. We may as well put in 5 because they want that one. If you put in 5 in this function, you get 5 minus 3 is 2. And that's enough. So you have to define g of -4 was this part, it's right here, equals 9. Or sometimes I like to see the work. You know, you might have said equals -2 times -4 plus 1 equals 8 plus 1. Show me. I like to see that. Okay. I'm a teacher. What can I say? I like to see your work. Don't leave your work off your test, please, because I can't read your mind. But, okay. Anyway, and then here I start with this closed, well, I didn't say g of 5 is, you have to use this definition is 5 minus 3 is 2. Okay, so I'm going to graph these. The closed circle is at -2, -5. And then I go to 0, -3, and to 5, +2. And, you know, it's basically, oh, you can't see that? Okay. So there's the, I went to -2, -5, then to 0, -3, 5, 2, connected those dots as a straight line. These are all linear equations, they're equations of lines. So here's the function g of x. And I make sure you've answered all the questions, what each one is. Some people in my other class already took this test, and some of them were plugging in -4 in both equations here and giving me both answers. They got 0 points for that. Don't give me both answers, because when x is -4, you can only use this one. So you have to put it in here. -2 times -4 plus 1. Now, even though on the open circle you do have to figure that out, but I labeled it open circle. Okay? You always have to put in where it's changing into both equations. But g of -2 is not 5. G of -2, we go to -2, and it's open there, so it takes on the value of -5 here. Oh, you can't see that. G of -2 is -5. The open circle means it doesn't take that value on. But why don't we start here with an open circle? Because then you're missing all of this. You're missing at -2.01 and -2.1. So you're going to be missing that part of the line if you don't start. You have to start where it's changing. Okay, any questions on that? Okay, now you get some time to work on the back. And you can work together, and you can ask questions. And I'm going to stop the video. Stop.